Hello and welcome back. In 1.6 we get into the idea of expressions. So an expression is a collection of numbers and or variables together with mathematical operators. One important note, an expression does not contain an equal sign. So some examples of an expression. The number 8 by itself is an expression. 5x minus 3 is an expression. 4x squared y cubed plus 8xy plus 7 is an expression. Another valuable concept to know, the idea of a term. So a term can be either a number or the product of a number with one or more variables. So for example, like above, 8 is a term. X is a term. The reason why, we are always allowed to multiply by 1, so this is still the product of a number with one or more variables. We can always think of it as 1 times x, so x is still considered a term. And we might have them both at once. 8x squared, y to the 19th is a term. Negative 4x squared, y is a term. So one thing to watch out for, terms are separated by addition. So for example, above here in this expression, we have 3 separate terms. Here's one chunk before the addition, second term, third term, 3 separate terms. And we'll look at a few examples of that. So we'll start with 5x squared minus 3x. So there we have 2 separate terms. We have the 5x squared and the negative 3x. So you do want to hang on to that sign out in front if it's a negative. So coefficients, hopefully you remember that from your 93 and 95 days. That is the number factor of a term. So those would be 5 and negative 3 respectively. And as far as like terms, they are considered like terms if they have the same variable or variables raised to the same respective powers. So we do have the same variable in each term, but not the same powers. We have 2 and we have the implied exponent of 1. We can always assume that something is raised to the first power if we don't write an exponent for it. So not like terms. Let's see. 2 times 7x squared minus 11x squared. Our terms, a little simplifying, would take us to a 14x squared and a negative 11x squared. Coefficients then would be a 14 and a negative 11. And since these have exactly the same variable raised to exactly the same power, they are considered like terms. Next, we'll take a look at x squared y minus 4xy squared. Pardon me. Terms, x squared y is one term. Negative 4xy squared is another term. Coefficients, if we don't write a coefficient, we can always assume we're allowed to multiply by 1. So 1 and negative 4 would be the respective coefficients for those two terms. And as far as like terms, we do have the same letters appearing. We do see similar exponents, but they're not attached to the same respective powers. That's what we mean by respective powers. If the x is raised to the second here, the x has to be raised to the second here, and that's not the case. So these do not count as like terms. And we'll do a plus. We've done a bunch of minuses. X cubed y plus 17x cubed y are terms. X cubed y and 17x cubed y. The plus we don't have to write down if it's assumed to be a positive coefficient. Our coefficients, again, the implied 1 and a 17. And here, same variables and same respective powers. X to the third, x to the third. Y to the first, y to the first. So these are considered like terms. All right, as far as the word factor, I did mention that word, and it is sort of commonly used. We're assuming you know at least some of the uses, but we do have two ways we refer to it. We refer to it here as a noun. Factor is one part of a multiplication, a product. So for example, 8x, 8, and x are factors since they're being multiplied together. So this is the noun version. There's also sort of a verb version saying factor. They're saying write it as a multiplication problem, usually using the distributive property. So we're rewriting a sum or a difference as a product. And again, that usually will rely on the distributive property. And in fact, the next problem we'll kind of walk through how we do that. And in this class, we'll be working with sort of two column proofs you've seen those in geometry class, the two-column proofs. So statements and reasons. What do we have? Why do we have it? So this was just given. They're asking us to factor using the distributive property, so I can rewrite each with a GCF. So here that GCF would be a 6x. And then we apply the distributive property. So not just what are we doing, but why are we doing it? That's going to be something we lean on a lot in late chapter 1 and throughout chapter 2. They may ask us to basically undo the work of factoring that's sometimes referred to as being asked to expand. So let's see, we'll do 5m by the quantity 7 plus 4m. So that is just given. We'll apply the distributive property. That'll give us 7m, or 5m times 7 plus 5m times 4m. And then we're using the commutative property of multiplication to change up the order. So commutative property specifically of multiplication. So we have 35m plus 20 times m squared. So at that point, we're just doing the arithmetic. So again, see if you can see how I'm dissecting these. Yes, you can. At least some of you can mentally skip from here to here if you want the points, though. Make sure you're going through the steps showing why it's working and doing the two-column proofs explaining the steps. Now we can also combine like terms using the distributive property. We'll do a 5x squared minus 18x squared. That will be our given statement. So really this is already factored in a way that we have our GCF of x squared. So we'll apply the distributive property by pulling the x squared. And then we just finish it off again with arithmetic. So you may not have recognized the distributive property looking this way. Recall before when we used the distributive property, we saw it this way. But remember, multiplication is, in fact, commutative. So I can change the order of that. I can move the b plus c factor to the front and the e to the back, and same thing with here. So really, we just kind of use this second version of it, where each one had an x squared attached, and we brought that common factor out. We're just moving it to the back of the line, not the front of the line, but multiplication is commutative. That is just fine. So same instructions again, just a new problem. We'll do px plus qx as our given. And this is really just a one-stepper. P plus q each had an x attached to it by the distributive property. And unless I learn something else about P and Q, unless they give me some values, this is as far as I can take that. Where before I had values that I knew what to do with. Here, if P and Q are still unknown quantities, that's as far as we can take this. So sometimes they'll give us the instructions that they want us to simplify. Let's see, we'll just kind of have that as our given. And we'll just take it one step at a time. So first off, I'd like to knock down the parentheses. That would mean I'd need the distributive property. So then we'll take care of the arithmetic. So 5x minus 20 plus x squared plus 7x. This is not the order we're used to seeing. Later we'll learn they're called quadratics. We're going to change up the order. See if you can figure out, as we're writing this out, what property it was that let me reorder this. See if you can come up with that property. So while you're thinking on that, now we have some like terms again. Distributive property comes into play again. And we finish it off with arithmetic. So that property that let us change up the order, we were moving terms around in an addition problem, so that's the commutative property of addition. Then the last thing they'll have us doing with these is evaluating expressions. So we're going to evaluate 5x minus 6y plus 8z for x equals -1, y equals 3, and z equals 10. So my x is a -1, my y is replaced with a 3, my z is replaced with a 10. Always use parentheses when you're plugging in a value where you used to have a variable. So this is substitution. And then from here, this is just an order of operations problem. So grouping symbols, I see 3 sets of parentheses, but no operations within any of them. So no grouping symbols to worry about. Exponents and roots, I come up empty-handed again, but multiplication division, we do have 3 multiplication problems, so we'll take care of those. So we'll have a -5 minus 18 plus 80. Multiplication division, left to right. And then addition subtraction from left to right, so -5 minus 18, -23 plus 80. Addition subtraction, left to right. And unlike signs, so subtract those absolute values and keep the sign of the number further from 0. This time it happens to be a positive. So 57, again, addition, subtraction. Again, from left to right. So that's the value under these circumstances. Different circumstances, they could give me 3 different values, and the same thing would be worth something else. All right, so that should be enough to try out the 1.6 problems, 1.6 exercises. If you have questions, please get in touch. Otherwise, I will see you next time. Stay safe out there.